Hey guys, this is Mr. Sal. We're going to go over 5.4 subtracting mixed numbers. Now remember, when you're going over these, to pause the video and try the problems, alright? Just pause the video before I get started showing you how to do the work. And then once you're ready, once you've completed that, then unpause the video and then see how we do it. You may have done it differently, but the answers should be the same. Right here we're showing the two methods, but there's lots of different ways to look at these. Some I've never thought about, which you guys may have. So as you look at this, just try your method on these, see if they work, and if they stop working, then maybe there's special cases for them, alright? But try them out, watch the video, and just double check your work. Now this is going to be different because, especially if you use that second method like we did with adding mixed numbers, because now instead of carrying over values, you're going to have to borrow values, which makes things generally very complicated for students. So just be aware of that. The first method, of course, is always consistent. It always works. We never have to worry about it. And that would be just changing these mixed numbers into improper fractions and then doing the subtraction, changing that fraction, if it's necessary, into a mixed number again. So keep that in mind as we move forward on this one. We're going to show the second method, which requires the borrowing. But you have to be careful with it, okay? So keep that in mind. I'm going to show both methods on this first example. So we'll start with the first method, the most consistent method, which I recommend using, at least until you get the hang of that one. Then I would use the second method. So this first method, of course, changing these numbers into improper fractions. So I'm going to do that with the cycle method. So that'd be 23 times 4, which appears to be 92. And then we'll add the 3, the numerator there, which would give us 95 fourths. So that would be 23 3/4 as an improper fraction. Then I'm going to change 11 1/4 into an improper fraction by taking 11, multiplying 4, which is 44, and then adding that 1 up there, which would then be 45 fourths. And we are subtracting these, right? So this one comes out pretty nice. After the subtraction, because we are dealing only in fourths, then I've got 95 of them, and we're going to take away these 45. So we're going to subtract those, right? And 95 minus 45 should be 50. So as an improper fraction would have 50 fourths, but we're going to change this back into a mixed number, right? So that would require some long division. So I'm going to take 50 and divide it by 4. 4 goes into 5 one time. So I'll subtract those 4, and I've got 1 remaining. We'll drop the 0 and make that 10. 4 goes into 10 2 times. 2 times 4 is 8, and I'll subtract that with a remainder then of 2. So as a mixed number, we get 12 with a remainder of 2 out of 4, right? Now, I probably should have noticed this. I didn't, but I noticed now because both numbers are even. 50 fourths, we could have simplified that if we wanted to. And you may have done so and made that 25 over 2. The reason I'm noticing now is because my fractional part of this answer needs to be simplified. And both of those numbers are divisible by 2. So we'll take the 2 and divide it by 2, and the 4 and divide it by 2, which would then make that 1/2. So my actual final answer ends up being 12 and 1/2. Alright, now I said I'd show that second method, right? So again, we're going to focus first on the whole values. I got 23 minus 11. And 23 minus 11, that should give us 12, right? And yeah, you should notice that the whole number from mixed number that we have as an answer is 12. But then I'm going to subtract the fraction. So that would be 3/4 minus 1/4, which is nice because the denominators are already the same. And 3 minus 1 is 2, so we have 2/4. So we really arrive at this answer right here just from that method right there. And it was pretty quick. We didn't have to use any long division. We didn't have to change any numbers with the cycle method. But again, just be careful. Eventually, we're going to have to use some borrowing on that. And you'd have to notice that the 2/4 could have been simplified. We had two opportunities down here, right? The 50/4 is definitely simplifiable, and the 2/4 is. So if I missed this one, but I noticed this one, you may have noticed the 50/4, which means you didn't need to simplify this one. Again, it just gives us more opportunities to notice if a fraction needs to be simplified. But in both cases, the answer is the same. So here's the next example. Again, the first thing I would notice is that the denominators of the fractional parts are the same. Now, because of that, I would at least try the second method. I would say, well, I'm going to take 5 minus 1, which is, 5 minus 1 is 4, right? So that's my whole value in the mixed number. And then I would take my 11/12 and subtract the 7/12. And 11 minus 7, that's going to give me 4 parts out of 12. Now, again, you have to stop and look at this final answer and just think, if at least the fractional part can be simplified. The 4 should be good at this point. But I know that 4/12, both of these are divisible by 4. So I am dividing both of these by 4, which would then give me 1/3. So my final answer here is 4 and 1/3. Now again, that was really quick. We didn't have to use cycle method. No long division. But again, there also wasn't any borrowing. And some of you may have noticed that because we need this first value, at least the fractional part, to be bigger than the second one. If these two were switched, then we would have to incorporate some borrowing, which we'll show with one of the examples in this lesson. But for now, I'm just going to leave this like this. Alright, so we could, on this one, we could use the same method. I'm not going to, just because I want you guys to get plenty of practice with both methods, particularly with the first one, right? Because, again, it's the most consistent. And so I'm going to use my cycle method here to change 11 3/4 into improper fraction. So that's 11 times 4 first, which is 44. And then we'll add the 3 there and make this 47/4. And yes, we are subtracting the 3 3/5. So again, another cycle method on this one. 3 times 5 is going to be 15. And then I'll add the 3 there to make this 18. So that would be 18/5. Now from this, just like we would need to if we were using the second method, is we'd need common denominators to subtract those fractions. And it looks like for 4 and 5, again, you could look deeper into it, but I'm just going to use the quick method by multiplying each fraction by the other or opposite fraction's denominator, which is going to give us an automatic common denominator, in this case of 20. So, for example, I got the 47 times 5, right? 47 times 5, that should be 235. And then 18 times 4 should be 72. And we are subtracting these. So the denominator stays the same. We still have 20th size pieces. But I have now 235 minus 72. In fact, I'll need to do that one up here. I'll show the work. 235 minus 72 gives us a 3. We'll have to borrow from the 2 there. Remember the borrowing. This is good to see, because eventually when we start using the second method, we're practicing it again with borrowing. It's essentially the same idea. So I got 13 minus 7, which is 6, and then I bring the 1 down. So I have 163 20ths. Now, if I could simplify this, I would, and I learned my lesson from that first example that we did. I'm looking at this fraction here just to see if it can be simplified, but I see that it cannot. 163 is not divisible by 2, 4, 5. It's not divisible by 10 or 20. So we're stuck with this. And again, to change this into a mixed number, I'm going to have to take the 163 and divide it by 20. Now this one happens to be very nice because I know 20 will go into 160 8 times. 8 times 20 is 160. So when I subtract that out, I have a remainder of 3. So my final answer here would be 8. That was the quotient with a remainder of 3 out of 20th size pieces. That right there would be the answer for this one. Now we should be able to look at this and just kind of think, and we've talked about this before in class, just kind of estimating in our heads. I don't really prefer formal estimating, but we should be able to estimate this in our head. This is almost 12 right there. That's about 12. 11 and 3/4. It's close to 12. And 3 3/5. I mean, it's 3 1/2. You could say you could say it's just 4. 12 minus 4 is 8, and 8 3/20 is pretty close to 8. So our answer comes really close to the estimate that we should have, and we should be able to figure out in our head or even on paper. All right, so I'm just kind of going back and forth between the two methods. Now, if you looked at this one and you're like, yeah, I'm going to change this into improper fractions. I'm going to find common denominators. I'm going to subtract. Then I will use long division to change it into a mixed number and then simplify if necessary. That's fine, okay, but I'm not going to do that on this one. I'm just going to go straight to method 2. First, by subtracting the 16 and 4. Now, I'm not even looking at this like, oh, the denominators are the same. They're not the same. And I'm not even looking at it like 4/9 is bigger than 5/18. It is, but I'm not worried about that right now. Just because I want to see if it is. Okay, so if you're like, I'm just committed to the second method, this is what I'm going to do. 16 minus 4, right? You'd have 12 there. Then would have to subtract the fraction. So that would be 4/9 minus 5/18. And we need common denominators. So I would take the 9 and I'd multiply it by 2 to get that 18 right there. And then I would have 8/18 minus 5/18, which ends up being 3/18. So right now the answer is 12 and 3/18, but again, you should always check to see if the fraction can be simplified, and this one can. 3/18, both 3 and 18 are divisible by 3. So this changes then to 1/6. And the answer is 12 and 1/6. So again, there wasn't any need for borrowing. It's coming. But if you go into this kind of blind, like I'm not really checking to see with those things that I talked about earlier in this problem, that's okay. Again, we'll show, I assume on the next page, that we'll see some examples that do require borrowing, and it's okay. We should be able to do those. Alright, so just to get us started on this one, again, I mean, at the top it says we're going to have to use some carrying. I'm saying it's borrowing. It doesn't really matter. At least on one of the problems. Well, the first one. You know what? I'm going to start on that bottom one. I am going to start on this one, alright? Now I'm going to show both methods, okay? Starting with method number 1, which is just to use the cycle method to change these into improper fractions, right? So cycle method, take the whole number, multiply it by the denominator. So in this case, I got 10 times 4, which is 40, and then add that 3 in the numerator. And then I have 43/4. Now this other fraction, right? I got 8 times 9, which is 72. And then add the 7 in the numerator to get 79/9. And yes, this is subtraction. Now again, our problem here is that we don't have common denominators. No worries, I'm going to use the quick method by multiplying the opposite denominator into the other fraction, both the numerator and the denominator. So again, this is nice. It gives me an automatic new common denominator of 36. But then, I mean, yeah, we got some kind of big multiplication right here, right? I got 43 times 9, which would be 27. Carry the 2. 9 times 4 is 36 plus 2. It's going to be 38. So that's 387. That would have been 387 36ths. And then I got 79. Let's show that 79 times 4 as well. So 4 times 9 again, 36. I'm going to carry the 3. 4 times 7 is 28 plus 3 is 31. So this is 316. 387 minus 316 36ths. And after doing the subtraction on that, looks like we'd get 1 there. 8 minus 1 is a 7. So 71 36ths. Now 71 is bigger than 36, so I do need to change this fraction into a mixed number once again. And to do that, we'll take 71 and just simply divide it by 36. 36 times 2 is 72, so that's not going to work very well for us. I take that back. It's just not going to go into it more than once. It's just 1. 1 times 36 is 36. And when I subtract that, sorry, I need a little bit more space there. Looks like I get a 5 from borrowing. 6 minus 3 is 3, so 35. So I have 1 and 35 36ths. And that would be the final answer for this problem. But as promised before we started, I said I would do the second method as well. Alright, so if I was to use the second method, the first thing I would do, again, I would take 10 and subtract the 8, which is 2. Now notice, our answer had a 1 instead of a 2 as the whole number. That's going to change here because of the borrowing. And then I would have 3/4 minus 7/9. And again, we need common denominators. We'll just continue to use that same method by multiplying each of the fractions by the opposite denominator, which is going to make that 27 36ths minus 28 36ths, right? Now the problem is 28 is bigger than 27, so I can't have negatives as part of this answer because we are actually taking away more than what we're taking away less than what we start out with. So I couldn't say 2 and negative 1 36. That doesn't make any sense, okay? Not that we've gone over negatives yet anyways. But what I'm going to do is I'm going to change the 2 into 1. And then, since we're dealing with 36, I would have 36 36ths. See how the total value of that is 2? Now, again, this is the part where people are like, you know what, I really hate this method. So if you're starting to hate it right now, don't worry about it. That first method will always work the way that I did it over here. Okay, so just keep that in mind. This method always works. This one can get complicated like we're seeing right now. Well, what does this do? It means that I can take those 36 and add them in here. So in other words, I have the 36 and the 27, which then make up, what is that, 63 minus 28? And again, this is in 36ths, right? And 63 minus 28, that would give us, well, let's see, I gotta do the work over here. 63 minus 28. I know not everyone needs the work here, but looks like I do. 5 minus 2 is 335, right? And again, that's the numerator for the answer that we're going to see over there. So it's now 35 36ths. I used up all of my 36 36ths when I put it right here. In fact, I'll put an arrow for that right there. And what was I left with? Well, I was left with this 1 and 35 36ths. which is the answer that it's the same exact answer that we got when we used the other method. So I use this third example on this paper because it kind of complicates things, right? Maybe you were like, man, I really like the second method, and then you see it kind of like this. That's okay if you get to this point and they're like, dude, I didn't know what the crap to do right here. Okay, that's fine. Use the first method. Use the first method. It is always going to work. It's always consistent. It will work every time, all right? But you still get to choose between the two. All right, so to the top of the page. Now this one's not, well, that still is kind of complicated, right? You could say, well, I'm going to use method 2 on this one. 25 minus 8. And what does that give us? 17, right? And then you got to subtract the fractions. Now again, this is where we run into the problem. We got a fourth minus 3/4. So we just don't have enough to take away what we have. It would take us into the negatives, which we haven't gone over yet. So what I'm going to do is I'm going to take the 17. I'm going to drop it to 16, right? But by doing that, I'm going to add 4/4 to the mix. So while I subtracted 1 from 17, I also added 1, which is just showing us 4/4 to this mix, and I'm adding it here. So this is all in fourths, which is great. That's what we want. We want them all in fourths. And I have 4 plus 1, which is 5, minus 3, which is 2. So right now, I would say that I have 16 and 2/4. But again, we should look at that fractional part and just notice that it can be simplified. Both these are simplifiable by 2, so we can divide it by 2, I should say. And that leaves us with 16 and 1/2. And that would be our final answer for this problem. Alright, for this problem, it is a little different. We got a whole number minus a mixed number. And what I'm going to do is I'm going to change the whole number and change it into a mixed number. And I'm going to do it pretty much the same way that we did before. And this is going to allow us to just subtract the fraction right there. So I'm going to make it a 5 and a 9/9. Now this would make the second method very convenient, right? And some of you guys, just by looking at it like this, know what the answer is, and that's great. Alright, but I'm going to skip that part for now. Just notice 5 and 9/9, the total value of that is 6. It's 5 and 9/9. Well, what's the value of 9/9? It's 1. So you have 5 and 1, which is 6. So if you're like, you know what, I don't even know what the crap just happened right there, alright, then you need the first method. You have to have at least the first method down, right? 6 minus 3 and 4/9. Now, the important part of this is to show the 6 as 6 over 1, okay? Because this ends up being 6 over 1, changing 3 and 4/9. 3 times 9 is 27, and then plus 4, that's going to give us 31/9. Yeah, and this is subtraction, right? Now, the problem with this right now is that the two numbers do not have common denominators to allow us to subtract the fractions. So I need to change 6/1 into something ninths. So I'm going to take the 1 and multiply it by 9. Therefore, I have to multiply the 6 by 9 as well, which is going to give me 54/9. So I have 54/9 minus 31/9, which would give us, finally, 54 minus 31 should be 23/9. Now again, you could use long division on this one. We'll show it. Not over here, but we'll show it here. 23 divided by 9. Hopefully you know 9 goes into 23 2 times. Which would be 18. Subtract, would have 5 remaining, right? So this ends up being 2 with a remainder of 5 out of 9 parts. And that worked really well, right? Now, you should have gotten the same answer from over here. Right, we know 5 minus 3 is 2. And then we had the 9/9 minus 4/9, which would have been 5/9. So we got the same answer either way. Again, I'm pointing this out because it doesn't matter which way you used, you should have had, or you should be able to see the same answer. Just because there was some borrowing on this one, because originally it would have been 6 0/9, I guess, if you want to write that as a mixed number. But by changing it to 5 5/9, then we have enough to take away 4/9 away from it. Alright, you guys, hopefully that was helpful for you. Thanks for watching. Notice at the end, right, like I said, that first method, it's always good, it's always consistent. But when in doubt, yeah, if you're like, man, I'm really confused, always go to method 1. Change your mixed numbers into improper fractions. Find common denominators. Do the subtraction. Simplify if you need. And then convert it into a mixed number. Alright, we'll see you in the next video.